Welcome to our February Dig Deeper webinar. I'm Jeff Hammond, Executive Director of the International Ground Source Heat Pump Association. We're thrilled to have Michael Ridler with us from Eden Energy this morning. And I have just a few slides here to give you an update on what's happening with IGSHPA and set the ground rules for our webinar, and then we'll turn it over to Michael. So with that, let's get started. Thanks for joining us this morning. Just some news on what's happening with IGSHPA. If you would like to participate in the Dig Deeper or Town Hall, and especially if you'd like to present, go to our events and training menu at IGSHPA.org. And if you would submit one of these forms, we're always looking for new topics, and we're happy to have the latest information from the industry. You know, whatever expertise that you have, we would love to take part of that. Also, we have sponsorship opportunities. Today's sponsor is Geothermal Exchange Organization, or Geo Exchange for short. So there's a form there in that same location, the events and training. Just click on Town Hall and Dig Deeper webinar sponsor, and you'll find the information there. Happy to say we now have a theme and graphics for our annual conference coming up at the end of the year. We're partnering again with National Groundwater Association, and it's back in Las Vegas, December 5th through the 7th. So you'll find all of the information on the website now. If you go to IGSHPA.org, you'll see this graphic at the very top, and now the registration is open. There's hotel information. We do have a block of hotel rooms that NGWA reserved. Last year, they went rather quickly. They're great pricing. So if you're going to the conference, which we hope you are, you'll want to register and take a look at that hotel information. Also, if you would like to exhibit at the conference, we have a great location. There's information there on for exhibitors as well. That's at IGSHPA.org. Just click on the conference menu, or on the homepage, there's a link to the conference information. If you haven't checked out our new business directory, this is a great way to find all the various stakeholders. If you're looking for drillers or contractors, distributors, manufacturers, engineers, whatever that might be, just click on the state or province, and that'll take you to a list of members. You can also do searches by the type of member you're looking for. And once you pull up that company, you'll have all the information. We'd like to welcome a new employee. IGSHPA just expanded by 33% over the past month. We now have 3 employees. So we welcome Angela as our administrative support specialist. You may be talking to her if you have questions about accounting, invoicing, billing, any kind of member inquiries, things like that. We welcome Angela on board. So if you see an email from her, or if you call in, you may have a chance to talk to Angela. Welcome, Angela, to the industry. As far as CEUs and renewals for your IGSHPA certification, you'll want to make sure that you let us know that you're here, and you can do that by sending a chat message to the IGSHPA account. Make sure you put your name and your email address in there, and we'll keep track of those for you. And then every half CEU interval, we'll send out notice so that you can keep track of those for your certification status. Just some quick housekeeping before I turn it over to Michael. Please enter your questions in the chat after Michael's presentation. If we still have enough time, I'll read those questions and we'll give Michael a chance to address those. If we don't get to everybody's questions, we'll follow up after the webinar. As always, please mute your microphone. It just helps everyone be able to hear Michael's presentation. And I'm sure it's going to be a great one, so we don't want any distractions. Just a quick disclaimer on potential conflict of interest. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA Town Halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry, and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. So with that, I'll stop sharing my screen and let me pull up Michael's introduction. Michael, feel free to share your screen whenever you like. Just a little background on our presenter this morning. Let's see here, I'm going to pull that up real quick. All right. So Michael started his career in a family-run HVAC company over 20 years ago that's still in operation to this day. Michael is the technical services manager at Eden Energy Equipment and is responsible for mentoring and advising the technical support team at Eden Energy. He's also focused on providing field support and technical training for contractors, engineers, and builders across Ontario on heat pumps, boilers, and hydronics. Michael is passionate about learning new things and building relationships with industry stakeholders in HVAC, both new and old. Michael Ridler is first and foremost a family man who lives to set an example of positivity, mentorship, and empowering the people around him. So with that, I turn it over to Michael, and thank you so much for presenting today.
Well, thank you, Jeff. I have to start with welcoming Angela. So let's just start with that. Welcome, Angela. It's great to have you. And yeah, now I'm not the newest person working with IGSHPA because that would be you. Want to just say thank you for the introduction, Jeff. And I want to thank all the people that put the time into me. Some of them are actually on this presentation today, I'm sure. I'm very proud of the work that I do, and I try to give back to this industry because of people who, invested a lot of time in me. That would be Jeff Hammond, Lance McNevin, Tom Kinder. It's a long list of people that have spent a lot of time with me over the last 22 years. And hopefully we have a great discussion today. So my role was identified as I'm the technical services manager for Eden Energy Equipment. For disclosure, we are the water furnace distributor in Ontario. But the objective of this presentation is not to talk about that. It's to talk about how we're going to apply water-to-water technology. And you can use this, whether you're working on ClimateMaster, Enertech, Bosch, Florida Heat Pump, it really doesn't matter. This is not product-specific discussion. So we're going to focus on a very specific discussion on best practices of the equipment, how we want to pipe it, how we want to install it, and how we can ensure we have a successful hydronic installation. And we're also going to talk about what's going to happen if we don't follow that successful installation process. So as technical services manager, I've had the hard knocks. I've installed equipment previously. I worked for a family-run HVAC company, and sometimes it didn't work as intended. And with the design knowledge I've gained over the last 20 years, we're going to talk about some of those scenarios and what has happened and what worked. So right off the bat, I want to go through some keys to what I would call a winning water-to-water installation. And I've nailed it down to 9 things that we have to pay attention to. So right off the bat, this whole presentation is boilers are not heat pumps. And the reason we're covering this is because a lot of water-to-water equipment gets installed as if it's a boiler, and you can't do that. You can't pipe a water-to-water or any hydronic heat pump like you would a boiler, or you're going to end up with problems. It could be simple as it doesn't perform properly, or it could be as complex as that piece of equipment catastrophically fails. So don't treat a boiler like it's a heat pump any more than you would treat a heat pump like it's a boiler. Furthermore, boilers, buffer tanks can sometimes be optional. And even in scenarios where a boiler needs a buffer tank, you can sometimes get away without using that buffer tank. Now, on a water-to-water application, buffer tanks are a must. We need to be using buffer tanks, and we're going to talk a little bit about the importance of the buffer tank and how it comes into play. Number 3 on my list is to pay attention to flow rates. It is really, really important that we understand the minimum flow rates for a hydronic heat pump. We're talking about water-to-waters, but this whole statement would also apply to the advent of air-to-water equipment. This equipment has different flow rate demands than a typical condensing boiler would, and we need to be conscious of that. Now, obviously, if we're using different flow rates for a water-to-water application, that also means our pipe sizing is different. And we're going to talk a little bit about why and how we need to address that. And then from a control strategy standpoint, I personally like to control around the buffer tank. And we're going to have a discussion about why I like that strategy and why I do it. The other thing I like to point out is a lot of people look at water-to-water equipment and go, wow, it's so much more expensive than if I was to do a boiler. And one of the key things that I see come up every single day with our customer service and our technical team is people will forget when they call in and they talk about a water-to-water that thing is not a boiler. It is heating and chilling water. It is a dual-purpose appliance. And in some cases, it's also doing domestic hot water, in which case it's doing 3 things. 7th on my list is the design aspect of this. We can go out and we can wing a lot of things. We shouldn't be winging water-to-water applications. We covered this in number 6. They are a little bit more money than a traditional heating system. It's really important that we follow a design, follow best practices, RTFM, read the free manual, because at the end of the day, warranty does not cover what I like to call the ID10T error. If we do idiotic things, then the factories that make these units are unfortunately going to have to put it back on us. And it usually is summarized quite quickly with, did you read the manual? Because the things you did not do are covered in the manual and covered in training. The other thing that we have to pay attention to is that what's water technology, we want to be designing for lower water temperatures by design. And I've got some examples in this presentation because the reality is that the hydronic systems we're doing currently, they will work as it stands right now with a water to water, just like they would with a boiler, as long as we understand the math and pay attention to it. And then obviously, if we're not working in a retrofit application, and if we're working on a new installation, we want to make sure that when we're designing systems, we future-proof them. And what I mean by that is do what you're doing right now. Come to training, spend time with people that are sharper than you and that come into these groups and can share with you, what are we doing right now? What new technology is on the market now? We don't have to keep designing our water to water installations like it's 2000 or 1990. I know me personally, I do training every single week, not just doing training, but gaining training so that I can stay up on my game. And I encourage you to do the same so you can future-proof your designs. And the reality is that if you do this training and put the time into doing the research, you're actually going to find your systems work better and they become more and more cost effective. The guys and gals that work off designs and actually put the time into understanding what they're doing are the ones that are more profitable, and they're the ones that have the jobs that succeed and work very well. Now, the other thing I want to just very quickly point out before we get into the technical aspect is, for me, there's 3 keys to a winning hydronic installation. And I want to touch on this because in a lot of cases, the first 2 are eliminated. We immediately go, we just need a great manufacturer. And I don't dismiss that. You need to be aligned with whatever manufacturer makes sense for you. There's a bunch of geothermal manufacturers. They all make great equipment. So you need to align yourself with a manufacturer, but I've put that 3rd on my list. The number 1 thing on my list is the contractor. So at the end of the day, if you are doing a project and you're an engineer or a GC, you need to align yourself with a contractor, because a really good contractor can take a piece of equipment that might be missing some features. And I'll even go so far as to say maybe it's a little bit mediocre in some ways, but a well-trained and well-equipped contractor can make any piece of equipment work great. And I speak from experience. So the number 1 thing is the contractor, and I would include the designer in that. A lot of the times it comes down to, how do I find that contractor? Use technology, go on social media, look up that contractor, look at photos of their jobs. And more importantly, if there's a job where there's been a photo posted, read the comments. Guys like me, and I'm sure many of you that are on this session, we like to share the projects we're doing and the reassertion from other contractors of, wow, what a great installation, or I like how you did this, or I like how you did that. It's a great tool for you to be able to find a contractor that can do the job right. The second thing I put on the list is make sure you're buying your products from a company that understands the water to water technology. You can have a great brand and you can be a great contractor, but what happens when you get into the weeds? And hopefully you understand what I mean by that term. I've been in the weeds when I was doing installation work, and I'll tell you right now, I didn't have a good distributor. I didn't have a Jeff Hammond or a Mike Ridler that I could call and say, hey, I need a hand. So I have these in as a key item to making sure that your geothermal hydronic installation will work, but you can take the word geo out, replace it with boiler, air source. I don't care what it is. It's really important that you have a good support system behind you so you can be a success with it. So the other thing I want to talk about is, why water to water? What is so special about doing a water to water installation? Well, right off the bat, one of the things that we're seeing is electrification is becoming huge. It's really big here in Canada, and certainly it's very big in the United States as well. And one of the easiest ways to address and adopt to electrification is by using a water-to-water hydronic heat pump, or frankly, any geo heat pump is a good start. The other thing to keep in mind is that as we go through this whole electrification approach, there is a sort of thought process of we have to eliminate gas completely. And, I am definitely the geo guy. It's quite clear, I'm doing a geothermal presentation, but there's nothing wrong with a hybrid approach. And we're going to show some examples in today's presentation. If we go into a home and if they've got a really large load, we could take all of their appliances out and replace it completely with geo. But would we be better if we had a 10-ton load to cover 8 tons of that with a water to water and top it up with a secondary fuel source for the 5 or 6 days out of the year where they need that fuel to get them to be comfortable? So the hybrid approach helps with upfront costs. It also makes sure we ensure comfort even in the coldest day. And I've just included this so we don't think immediately that electrification means no gas. It has to be all geo. We can't have anything else in the building. And then the other thing that comes into play, and what I really like about a water to water versus doing anything that would be a traditional geo unit, is that water is a much better medium for delivery of BTUs. If you look at the table on the right that's courtesy of Calliope, you can see the heat capacity of a whole bunch of different materials. And we're used to air. And the reality is that the heat transfer of water is 3,500 times higher than air. So what that means is we've got an opportunity to deliver a lot more BTUs in a much smaller space. The other thing I want to caution, though, is that although this water to water is going to be much more efficient than any other system, it again comes back to my original slide. If you don't have a good contractor, if you don't have a good distributor, and if you don't align yourself with a good manufacturer, an improperly installed unit will kill the efficiency story quickly. The number one thing that gives our industry a black eye is a bad installation. And we all collectively need to work to resolve those, because nobody goes out and says that water furnace unit didn't work, or that Climate Master, or that Enertech didn't work. They say geothermal doesn't work. And we need to proactively collaborate and work and make sure that all of these systems work regardless of who put it in. And the other thing that's worth noting here on water to waters, again, not to be causing a scare factor, is that boilers are quite forgiving in how we install them. Water to waters are not quite as forgiving, so we need to pay attention to how we're installing and how we're making them work. But as long as we have a good contractor, a good design, and a good unit, we know that using water as our medium for heating is very, very efficient. If we put that into perspective, if you looked at a 3/4 inch piece of PEX and what would it require to deliver the same amount of BTUs, you can see it in the illustration on the right that comes courtesy of Calliope. I could deliver the same amount of BTUs with a 3/4 inch piece of PEX that I would with a 14x8 piece of ductwork. The other thing that's very significant is I have the very easy, low-cost means that I can now do zoning in every single room in that house. I'm not saying you would, but if you had a client that said, I want to have a different heating climate in the master bedroom and the guest bedroom, literally for less than $100, we can do that. And if it's a retrofit application where they say, hey, we just put a granny suite over the garage and we want you to heat and cool that space, well, it's very easy for me to get a 3/4 inch piece of tubing into that room. It is very difficult for me to get a 14x8 piece of ductwork from the mechanical room up into that new granny suite or whatever it may be. So the reality is a water to water is very adaptable to many different heating and cooling sources, and we can deliver a lot of BTUs. If we had a massive house, and at Eden, we work on huge houses, 20, 30, 40,000 square feet, and believe it or not, they're putting geo into these, you can deliver easily 1 million BTUs if you needed to. And even then, we're only at a 3-inch piece of pipe. So we can deliver a lot of BTUs, which makes it easier for you to do the installation, and it makes it very, very efficient and comfortable for the end user. Now, I'm sure most people understand how this equipment works, but I've thrown a few slides in just as a quick illustration of what happens. So what we're doing is we are passively moving energy out of the ground in the heating mode. We call that our heat of extraction. So on the 4-ton unit, we're extracting 36,000 BTUs. We're putting it through the compressor circuit. That compressor circuit is where we're picking up that extra energy, and we're delivering that total heating capacity into the space. And in cooling, we're doing the exact same thing. It's reverse. We're taking the heat from the space and we're dumping it and rejecting it out into the ground loop. So the easy analogy that I use when I'm explaining how this works, the cooling is the easiest, is think of it like a fridge. We put our food into the fridge, and if we were to put our hand behind the refrigerator, we would find it's really, really hot. Well, we're rejecting the heat that's from that food out behind the fridge. A geothermal unit is doing exactly the same thing. We're rejecting or we're extracting heat using a compression circuit. The other thing is you will run into scenarios where people will say, well, you could do an air to water and be as efficient as a water to water. I personally have an air to water installed in my house. The reason I installed an air to water in my house is I have no chance of putting a ground loop in. My air to water, when it was minus 25 last week, would not perform like the water to water, because the water to water does not care if it's minus 25 outside. The ground temperature is stable year round. We don't have those conflicts. So both are great technologies, but they are sort of an apples to bananas comparison. So two different technologies, two different applications. The water to water is a very viable, stable heating and cooling appliance, regardless of what the outdoor air temperature is. If we look at how the piece of equipment is installed, I've put together a little schematic so we can sort of go through it quickly. The key thing to keep in mind with a water to water, or frankly, any geothermal piece of equipment, is you have a compressor bearing unit that is installed in the home. Be conscious of where you're installing that. If the homeowner calls you and says, hey, we'd really like you to put this 5-ton water to water in the master bedroom closet, please don't do that. You know, we joke about it, we chuckle and go, that's funny. I personally have been called to job sites where the homeowner complained of noise and the unit is installed in the closet of the master bedroom. So compressor bearing unit, we want to make sure that we install it in a properly located mechanical room that is properly insulated and noise proofed if necessary. Make sure you're installing it on top of an air pad. These air pads come in a variety of different flavors. It's a 2-inch high density polyethylene base that it'll sit on. That makes sure that those compressor noises are not going to transmit out into the space. Don't put the water to water on top of any sort of raised platform because it will resonate. And the other thing I would say to you is if you have 2 units, do not stack the second unit on top of the first one. If anybody's ever had to replace a compressor in a water-to-water unit, you know exactly why I'm telling you that. If you have to take a Sawzall to cut a hole in the side of the unit to get the compressor out because it's supposed to come out of the top and you stack something on top of it, it's going to be a problem. So make sure you put the unit in, install it properly, read the manual, speak to your distributor, ask questions, make sure that you're not just installing it for right now, but you're installing it that you'll be able to service it later. The other thing is the flow center that I have on this, obviously, don't DIY this. Don't go out and go, well, I can go and buy my own circulator and install it. Sure, you might be able to meet the flow rates that are required, but how are you flushing it? How are you commissioning it? A DIY on the flow center side is really not a good idea. In residential applications, in the long run, it's going to cost you more in labor, more in irritants. I would encourage you to use a standardized flow center regardless of what manufacturer you choose. As I move over to the right on the water-to-water equipment, you can see I have a geothermal storage tank hooked up to that unit. There are a whole variety of them on the market. Pay attention to the dip tubes that are inside of the units. There are typically multiple connections on the top of the unit. In some cases, there are also connections on the side of the unit, as you can see illustrated here. The one that I am using personally has 1.5-inch ports for the water-to-water, which is absolutely essential. We do not want to be using 3/4-inch tappings going into this unit, and we're going to talk about why later. And then when we connect to the top of the unit here, you'll notice that I have 2 cold line dip tubes. Again, if I was to hook these 2 lines up on these 2 connections here, I'm actually not properly stratifying the tank, and I would end up with a tank that is not hot on the top and cold on the bottom. I would have a tank that is pink everywhere. What would happen if I hook the loads up to these 2 ports on the right-hand side where I'm highlighting is the customer will complain to you, I don't know why, but when the heating comes on, it seems to take 30 minutes before we have any heat going into the space. And typically that comes back to a piping issue. And sometimes it's as simple as you've inadvertently hooked your supply and your return onto the cool water connections that have dip tubes pushing into the bottom of the unit. The other thing I'd like to note here is be careful. This particular tank that we use is made by A.O. Smith, but there is a whole pile of them, including great ones from Flexcon and others. I'm pulling off an 1.5-inch port on the bottom of this tank that is designed to be a connection port. Do not pull out a drain valve off the bottom of these units and use that as your connection going back. If you have sediment in that water, and I will just say right now, you will, it's going to form on the bottom, and you can suck that back inside of that unit, and you can cause component failure inside. One of the ways to get around that, and you'll see it's illustrated in my drawing, is make sure you're using a good dirt separator. I am saying dirt separator, not Y strainer, because dirt separators are way more efficient than a Y strainer. And best of all, when a dirt separator collects its sediment, it sits in the bottom and doesn't restrict the flow. A Y strainer, if not properly maintained, is not the fault of any contractor or engineer on this call. But the reality is when that Y strainer gets plugged, they're still going to blame us. So let's avoid that completely. Use a dirt separator, whatever brand you choose, to make sure that anything we suck out of the bottom of this tank, the dirt separator is the dirt separator. If you don't do that, your pump will be your dirt separator, and you don't want that. That's a very expensive part to have to keep replacing because you don't have dirt separation, or better yet, simply don't pull off of the very bottom of the tank. In the case of my tank, this port is about 18 inches from the bottom of the tank. I don't have any concerns of sediment building up to that point. I'll talk a little bit about the secondaries piping here. I have a air separator. Any sort of air separator you're using is fine. This is not an air vent. There is a misconception, and I certainly had it when I was still installing hydronic systems, that we want our air elimination at the highest point and we want to be using air vents. That is simply not the case. We want to be using air separators because inside of this air separator, inside the body, it has what's called a coalescing media. What that does is it collects all of the microbubbles out of that system and expels them out of it. With an air vent, we put the air vent at a high point because we're trying to catch all that buoyant air that gets up into the high points and get it out of the system. Well, the reality is that air is there, but we should get rid of it before it goes there. So if we looked at the system, if I fill this system with 60-degree water, 4.7% of that water is in fact air. And the way that air comes out is as we heat it up. The easy example would be I put a pot of water on the stove and I turn it on, and as long as I'm not staring at it, it's going to boil. If I'm looking at it, we all know it will never boil. So as it boils, what's happening is we're squeezing all the air out of it. Well, that's what's happening inside of our system as we heat the water up. So why would I put my air separator at the highest point? The air separator needs to go at the hottest point. The expansion tank and the backflow autofill, I'm just going to leave that alone, but those go at the point of no pressure change. And then you'll notice down here that I have 3 circulators that are all side by side on the system. Now, what can happen is people could take a drawing, and this is a conceptual drawing, and they go, I just saw Mike do this in a PowerPoint presentation. I'm going to copy verbatim what he's done here. So they would do this piping in 1 inch, and maybe they've run 1 inch to each one of these pumps. That is never going to work. This piping right here is sized so that it's less than 2 feet per second. So it is a short, fat header with very low flow velocities. And by doing that, as long as I keep velocity under 2 feet per second, these 3 pumps can be piped in like this, and you will have no pump competition. If this piping is all 1 inch here, and it's 1 inch feeding up to these pumps, depending on which one of these has a smaller circuit of tubing, or better yet, if this is a large pump and these 2 are small pumps, this bigger pump will have a bully effect and these 2 pumps will not get heat. So you will end up with scenarios where the customer will call you and say, this is my bedroom, and on Mondays I get heat and on Fridays I don't. And you're going to go, well, that can't be. And what's happening is this pump is tiny, this pump is big, and you have pump competition. So don't ever look at a mechanical or a conceptual drawing and just copy it without understanding the math behind it. And this again comes back to my comment of this is not a function of the manufacturer. It is not the manufacturer's job to tell us how to pipe it. The manufacturer's job is to tell us how to install this. It is the contractor and the distributor's job to make sure that we're doing this part of the system properly. The other thing that I'm showing here is I've got my, it's labeled as geothermal storage tank. It's actually my domestic hot water geothermal storage tank. So it's going to be the same conversation. Do not pull directly off the bottom if you can help it. We want to make sure that we're not sucking sediment off. So as you can see, I'm pulling off the cold water in and going through the system. And then the other thing that I would caution you is I am perfectly fine with doing a single tank application, assuming that it is not a gas water heater. If this is a gas water heater, my burner is sitting in the bottom of this. It's never going to produce any domestic hot water because it can't. It's actually sucking hotter water back through this unit. And believe it or not, it's going to negatively impact your ground loop and your equipment performance. So we want to make sure we pipe these appropriately. The good news is how to pipe a domestic hot water tank, how to install the unit, and how to do the storage tank is all firmly covered in every manufacturer's installation manual. The other way we can do a domestic hot water piping, which I'm showing here, is you could have 2 tanks. So this would be a good application where you had that gas water heater and you don't want to impede the operation of the unit. So this here might be your gas water heater, but you've got a preheat tank, and that tank would typically just be lukewarm. Even if we got that tank up to 90 degrees, well, this tank now is lifting water from 90 to 140 instead of having to lift it from 50 degrees to 140. Again, the reason I'm saying 140 is I want you storing this tank at a temperature where bacteria won't grow, and not shown here, which would be required, is we want to make sure we have a mixing device. Because regardless of what code dictates, nobody on this call wants to burn a child or anybody for that matter, because we've charged this tank with very hot water. It comes out of an outlet and hurts somebody. Another thing that I want you to make note of is the use of closely spaced tees. So I'm sure you're all familiar with closely spaced tees. So I've got a circulator that feeds around the system. Earlier in my drawing, you saw I was not using closely spaced tees. The challenge in doing this is if my water to water is putting out 120-degree water and I feed out to this first circulator at 120 and come back, what's the temperature going out to the second one at? Is it going out at 120 or is it going out at a lower temperature? What happens when you've got 6 or 7 of these pumps in a row? I can tell you from firsthand experience. This one's fine. The homeowner's happy, they have heat. This one might be fine too. The homeowner's happy and has heat. You could be in a scenario where this one is not getting what I call usable heat because the water going out to it might be 90 degrees and you designed your radiant system expecting to see 120 degrees everywhere. So you can end up with a temperature cascade that was unexpected. Typically why you see people doing this is it's an old school, very reliable way of doing it. Every boiler installation that I did was piped like this because it was how I was taught and mentored, and I didn't know better. This is the same conversation. If you come to new training, if you spend time with IGSHPA, they do a lot of these webinars where we can teach you really creative ways to pipe it where this doesn't happen. And the reality is that in my drawing that I just showed you, it is a lower cost way to install it where everything has the same water temperature and it's a win. So that's the comment where I made earlier of if you design your systems properly and think about them, that design system from a capital cost standpoint will be less than the contractor that goes in and either wings it or just misapplies the theories that they've learned. So we want to try to avoid that as much as possible. I also wanted to touch on some of the performance affecting parameters that impact a water to water. I'm not going to go through crazy detail on here, but I just wanted to list it. There's a recording of this, so you'll be able to go back and watch the recording and pause and get into more details. The key things that we have to pay attention to that affect the parameters, and number one is the entering water temperature. You don't have a lot of control of what the entering water temperature is in when the ground loop is in, but you want to make sure you're designing your ground loops properly. Don't be doing it with a rule of thumb, or we've done it for 20 years and it worked great like this. Make sure you're designing them, either software assisted or otherwise, to maximize the entering water temperature. The higher the entering water temperature going into the equipment is, the better for the overall COP and performance of the equipment. In the same token, the entering load temperature is equally important. The entering load temperature, we do have control over. We have control over the entering load and we have control over the leaving load temperature. The closer that I can get the entering ground loop temperature and that leaving load temperature, the more efficient this system is going to be. And the way that we do that is we want to make sure that we design our systems. We don't just go in and throw a bunch of PEX tubing down on a slab and go, okay, we know that this water to water unit can produce 130-degree water. Let's run it at 130. Well, what did you do to your COP? What did you do to the efficiency? And we're going to talk about that. The other two things that are very, very important that really gets overlooked is we have to pay attention to our water flow rates. We have full control over the ground loop water flow rate, and we have full control of the load side water flow rate. The two most common things that I see killing equipment, and I have 22 years of experience to back this up, helping contractors across Ontario, is inadequate flow rates and improper piping. The two most common things that'll kill a piece of equipment. So pay attention to your entering water temperature, pay attention to your leaving load temperature, and make sure you're following with what the actual flow rates for the equipment should be. I've dropped the table in here for a typical water to water piece of equipment. Again, I'm not going to bore you with the great details. I'd like to point something out to you. Where you see these flow rates over here, so this is 30-degree entering source temperature. They show a 3 gallon a minute, a 4 gallon a minute, and a 5 gallon a minute. And again, this is one of those, you don't know what you don't know. I, a few years ago, had a consultant call me up who did about 100 units in a building and said, hey, we're having nuisance lockouts with this equipment. And I helped this person out over the phone and I asked her, what flow rate did you use? And she said, well, I used the 3 gallons a minute that was published in the manual. Well, this 3 gallons a minute is for an application that didn't apply to her. So what she ended up doing was installing over 100 heat pumps with a flow rate that you couldn't meet. By the time I got the phone call, the job was done. So as we look at these tables, they're quite intimidating, but just because you see a load flow of 3 gallons a minute doesn't mean you should be doing 3 gallons a minute. Lean on the manufacturer, attend the training, talk to your distributor, make sure you're comfortable and understand what does it mean if I feed 3 gallons a minute versus 5 gallons a minute through this piece of equipment. Again, as we look at the water-to-water performance and affecting parameters, we want to know that our COP, the overall efficiency of that unit, is impacted by the delta T between my source and my load water. So if my ground loop's coming in at 30 and I'm putting it at 130, I've got a totally different COP than if my ground loop's coming in at 30 and I'm leaving at 90 degrees. Now, some people would look at that and go, well, Michael, you can't heat a house with 90 degrees. And I'm going to prove you wrong because I heat my house with 95-degree water. So great for a water-to-water application and definitely will work. The other thing we see a lot of is the 150 degrees. There's a lot of old boiler systems that are getting retrofitted with water-to-waters. And just because the boiler was set to 150 doesn't mean the water-to-water needs to be set for 150. Typically, historically, if something gets piped wrong, the easiest way to fix it if you have a boiler is just turn the water temperature up, right? We have a piping issue. We can't figure it out. You know, we hired Lance McNevin. Hi, Lance. I know you're on the call. You know, he's designed the system for 120, but we've done something wrong. So we'll just turn the water up to 150, 160, and it'll eventually heat up. You can't do that with a water to water, which is where we need to pay attention to it. And the reality is there are very slim scenarios with a hydronic application where I need 150-degree water. So we want to make sure we use the lowest water temperatures as possible to ensure we have the highest COPs. Here I have a table to illustrate that. So if you looked at having a 30-degree source with an 80-degree entering load water temperature. So if you think about that, you've got 30 degrees on the source and 90 degrees on the load. And I just told you I'm heating my house with 95-degree water. That means you have a COP of 4.5. If we did the same thing where I know I can heat myself with my house with 95 degrees, and let's just say the technician that came to my house didn't know that, and they just knew the water to water could produce 120. So they said, okay, I got a 30-degree source. They don't even care, but they're going to set it up that's got a 120-degree entering load. Just by not asking the question or reading the design, they took a system that should have been 450% efficient and turned it into a 250% efficient system. So we need to pay attention to what are the design conditions and why are we designing it. So this is what I'm referring to when we say future-proof your system. If you're going to install a system with a design, every single day of the week, you are going to be more efficient and more cost-effective than your competitor. And who do you think is going to get the referral and get the repeat business? The company that goes in and designs a system for 2.5 COP because they don't know better, or the company that goes in and every one of their systems is running at a 450% efficiency? And again, this is not rocket science. This is quite literally designing your systems up front, putting them into CAD, or just understanding the math and doing it with a notebook and designing your systems for the water that makes sense. The higher we drive those water temperatures, the negatively ways that we can impact that equipment is significant. What does this 2.5 COP mean to the homeowner? It means they're paying more on their bills every single month. And to fix it is very, very easy. Pay attention to the design and set it to the water temperature you need, not the water temperature it can do. So again, a little chart just to sort of illustrate what's happening here. We've got different temperatures. So we actually managed somehow to have a difference of 30 degrees between the source and the load. You would end up with a piece of equipment that has a COP of 7. So let's think about that for a second. I've got a water to water that's pulling water from a ground loop. How on earth would I ever get that to the point where there's a 30-degree difference between my ground loop and the water temperature I need? And a lot of people will look at that and go, well, Michael, you can't do that. You absolutely can. A lot of people look at solar thermal technology and go, solar thermal makes no sense. You know where solar thermal makes a lot of sense? To supplement a ground loop. If we could lift that ground loop, and I'm not saying you need to lift it to 30 degrees, we can keep coming down this chart and realize that a few solar thermals on a panel that are on a roof that are assisting a ground loop make a huge difference to the overall performance of that equipment. I personally have been involved in a water-to-water installation with Queen's University where we designed it where the entire unit ran off solar thermal panels. I am not advocating for you guys to do that. What I'm saying is think outside of the box and understand that the temperature difference that you see here between your entering source and your leaving load, the closer we can creep those together, you can end up with really, really impressive COPs. Going to talk really quickly about PEX. Obviously, PEX is fantastic, but a couple things to pay attention to. And I've heard this before that, PEX is PEX. It's not true. And, there's 3 different methods of making PEX. And the reality is in the making of those different types of PEX, what the end result is PEX A, PEX B, and PEX C all have different temperature pressure burst ratings. So if you don't pay attention to that, you can end up with a world of hurt. And I have a picture for you. What happens if you put PEX onto a system that's not designed for the temperature that's on it? Well, the PEX is going to fail. So in an effort to save 3 cents a foot on my PEX, I decided to get something that was more cost effective. And again, nothing wrong with that PEX. You could have used that easily for your hydronic floor, but you should not be connecting that up to a compressor bearing unit unless you understand the temperature pressure limitations of that unit. The other thing that I'll point out to you is that you have to be aware that inside of this unit is a compressor. So what happens if this pump that's hooked up to this compressor bearing unit fails? The water that is sitting inside of here that is not moving because this pump has failed, maybe it's pulling off the bottom of the buffer tank where it pulled all that crap, and this pump is now a dirt separator, not a circulator, and it's failed. This pipe can potentially rupture and cause a flood. I can tell you, quite unfortunately, that I have received many phone calls in 22 years from contractors going, "Oh, Mike, you're never going to believe this." They flooded people's basements all because they ran PEX directly to the unit. So my recommendation is if you're going to use PEX for any sort of piping that's near the actual appliance, use a PEX A product. And if you're going to be connecting to a water-to-water unit, I would encourage you to do it in rigid piping. Do it in copper, do it in PPR, or at the very least, put 18 inches of copper off of the compressor so that should this pump fail, this compressor has time to lock itself out before whatever plastic you've connected to it could potentially fail. As far as buffer tank sizing goes, I think everybody should be relatively familiar with how to size a buffer tank. There's a lot of really great independent research that comes from the IGSHPA folks and also from the Geothermal Consortium in Europe. We want to see these units run for 10 to 15 minutes to be able to maximize that efficiency. The analogy I like to use is if I had a really fancy bike, I don't know anything about cars, it's going to be a bad analogy, but let's say I bought a really slick motorcycle that goes really fast. Well, if I took that motorcycle into the city where I live, and we've got red lights like every block, and if I just redline that motorcycle as fast as it could go between each and every red light, how do you think the engine in that motorcycle is going to turn out? I mean, everybody around me is going to think I'm an idiot because it's going to sound horrible. Imagine me just ripping down the street. Well, the reality is if we undersize our buffer tank and make our heat pump do that, it's going to sound horrible. It's going to sound like Mike racing from stop sign to stop sign in the car. And the other thing that's going to happen is we're impacting the overall efficiency. We want to give this unit a long enough runtime that it can stabilize and maximize its COP. If you've designed this thing for a COP of 3 with entering source and leaving low temperatures, the reality is it has to have enough time to stabilize to get to where you designed it. And if the unit's just banging on and banging off, it negatively impacts the efficiency of the unit. So make sure you're properly sizing your buffer tanks. Make sure that you are, in fact, doing the math behind it. And again, read the manufacturer's manuals. They have great guidance on it. Not trying to cherry pick. I have no relationship to FlexCon, but this is a really, really cool buffer tank. This buffer tank has 2 connections on the left-hand side, 2 connections on the right-hand side. Best of all, the smallest unit has 1.5 inch connection ports, which you need at a minimum for a water-to-water, and the larger units have 2-inch connections. Because it's got 2 connections on the left-hand side and 2 connections on the right-hand side, it also has this huge wide volume of water here. So some of you might look at that and go, that kind of looks like a hydraulic separator. So the other thing this thing does, not only in being your buffer tank, is it allows the hydraulic separation between your water-to-water and your load, so you don't have to worry about pump competition, and you don't get that phone call of, we paid Lance to design this, and for some reason the heat's not going where it should be. It could be as simple as you don't have good hydraulic separation. So having a buffer tank that acts as your hydraulic separator is a really good bonus. So the other thing I want to touch on is piping. It's really, really important that we actually size the piping properly for these units. Typically on a water-to-water equipment, we want to see 2.5 to 3 gallons per minute per ton. And so what I've done is on the bottom of this slide, I've put together a few different BTU calculations. And what I've done is I've looked at it from a boiler perspective. So if I was out today and wanted to install a boiler, and let's say I had a 65,000 BTU boiler, I could put 3/4 inch piping on that, no problem. And I've put a few examples here. And I sort of want to focus on this one right here, this 3/4 inch pipe on up to 65,000 BTUs, because it happens a lot. What'll happen is you'll get a 5-ton water-to-water unit. You'll go install it and go, well, every boiler I ever put in that was 70,000 BTUs, I put 3/4 inch pipe on it. There's a problem with that because what we're doing is we're ignoring this line in my slide. And I'm going to show you the math behind that. So if we look at it, this is the boiler that I have in my house. So if I look at 10,000 BTUs, it's 1 gallon a minute. How do we get to that? We got 1 gallon a minute times my constant for water times my delta T. So it says for 1 gallon a minute, I'm going to get 10,000 BTUs. It's a 65,000 BTU boiler, so it's 6.5 gallons a minute. I haven't shown it here, but I've done the flow velocities and the pressure drop on that. And the reality is that 1 inch or even 3/4 inch piping on that, you're going to be fine. You're going to be able to deliver that 6.5 gallons a minute. You're not going to have any complaints. The heat's not stuck in the boiler. The heat is getting out where it needs to be because there's not a bottleneck in my piping. Well, let's take that same theory and let's apply it to the same size water-to-water unit. So 2.5 gallons a minute is my minimum to get me my 10,000 BTUs. What's changed here is this. If you look at our water-to-water equipment, it doesn't have the ability to lift the water 20 degrees. You read the manufacturer's manuals, they'll tell you it's 5 to 8 delta T expected on the unit. You might get a little bit more, you might get a little bit less. So when you do the 2.5 gallons a minute times 500 times 8, you find out, hey, look at that, we're at our delta T. So 65,000 BTUs in the case of this unit is actually 16 gallons a minute, not 6.5. If I put 1 inch piping on that, my flow velocity is way too high. At 6.35 feet per second going through that piping, we have a whole bunch of problems. And that's not even talking about the restriction, the bottleneck. The example of this would be the fire department pulling up outside of this building to put the fire out. Instead of taking a giant hose off, asking me for a small 1/2-inch garden hose to hook up to the fire truck. They're not putting a fire out any more than I'm going to deliver the BTUs into the space. So it's really important that we pay attention to this. And the reality is that the manufacturers tell us this in their actual manuals. And all we have to do is actually read that free manual. Or again, you as the qualified contractor, go back to your distributor, spend time with their technical team and have them walk you through this. So if I looked at it, if I had a 5-ton NSW unit, and if the pipe velocity was at 3 feet per second, the total head and flow requirement for that unit is 15 feet ahead in the unit at 18 gallons a minute. Whereas if this was a boiler, I would be 6.5 gallons a minute, 6.5 gallons a minute, and I might be 3 feet ahead. So the other thing that comes into play here is people look at these little units and they go, well, when I have a 65,000 BTU boiler, I'll put a little 1558 or a 0015 circulator on it. You can't do that on a water-to-water. You need to make sure that you're paying attention and reading the manual and understanding not just what the manual says, but how did you pipe this? What is the actual pressure drop in the system and what flow rates are you trying to achieve? So as you can see here with these examples, that's assuming it's properly sized piping. So with these units, the factory is asking you to put 1.5 inch piping on it. Well, what happens if we did 3/4, right? We had already said earlier, my boiler that's 60,000 BTUs, I have 3/4 inch piping on it. I'm not even showing 3/4 because it's so bad, it's terrifying. If I was to do 1 inch piping on this, my flow velocity is so high, it's going to be a significant problem. What's worse is I now have a scenario where I'm going to have a hard time pumping that with a residential circulator. 18 gallons a minute at 23 feet ahead, that's a really big and expensive residential circulator. Instead of doing a smaller circulator that might be $200, I'm now buying a $2,000 circulator because I didn't read the manual, or better yet, I didn't follow the design or I didn't ask for a design. The way that we fix this is quite literally by paying $20 more, and instead of buying 1 inch pipe, buying 1.5 inch pipe. So again, work off of a design. Don't be afraid of that design. And if you have a good distributor, they will have engineers and tech people on staff. Speaking for our company, we have an entire technical team that is paid by Eden Energy, and we have 2 engineers on staff. And I don't think we're a unicorn. Every state, every province will have really good distributors that represent geothermal products that can help you to design the system so they're going to work. Now, the good news or the bad news, depending on how you look at it, is manufacturers will tell you the pipe size, right? So again, if I take that unit, this unit right here, that'll give me 60,000 BTUs, and I put 3/4 inch piping on it, I'm telling you right now, that unit is going to die. The compressor is going to fail in that unit. You're going to ask for warranty, and the factory is going to ask you for a picture. And it's not so they can put it on social media and say, look how good this install is. They want to know, what size piping have you hooked up to that unit? And if you've got 3/4 inch piping on that, well, you didn't read the manual. The other thing is, notice the flow rates. This is an advertised flow rate. The flow rates that I gave you guys earlier were my flow rates that I calculated. So my calculated flow rates are very close to what the factory is asking you to do. They'll even go so far as say how far you can run that 1.25 inch and how many elbows you're going to have. The other thing to keep in mind too is if you're putting a 20-gallon buffer tank on the unit, it's not enough buffer, the unit's cycling too much, you're losing capacitors, your compressor's really loud. Again, if you go back and complain to the factory, they're going to ask you, how big is your buffer? And if you tell them, well, I just used a water heater that I got at Lowe's, they're going to have lots of questions for you. You'll see the minimum size buffer tank in this table is an 80. The ideal is a 120. So this is good, but it can also be bad. If you read the free manual, you can see everything you need to know from the very basics of how to connect that unit. If you don't read the manual, you are going to have failures. And at the end of the day, you're going to have really hard time with warranty because they're going to send you the page in the manual that for whatever reason you may or may not have read. So if we don't pipe it right, and if we don't use the right circulators, what's going to happen? It's the motorcycle analogy. If I'm ripping down the road for every red light, it's going to be loud. Well, if I make my water to water, have to rip really hard to deliver BTUs, it's going to be really loud. It's noisy because we're not rejecting the heat off the water to water. It's literally a constipated heating system. It's generating hot water, and the hot water can't go anywhere because the pump's too small, the piping's too small. What ends up happening as a result of this? Well, we also end up getting head pressure lockouts. You'll end up having high pressure lockouts because you're literally redlining that compressor, and that's going to result in significant component failure. Symptoms that'll show up, typically the customer will call and say, I'm not comfortable. I paid you to install this system, but the thing they paid you to do is deliver comfort. And if we don't pipe and pump it properly, we're not going to do that. We're going to run into performance and comfort issues. And from my own experience, typically the electronics start to fail first. Then you start losing compressor capacitors. And then if you still haven't caught on to what's happening, you're going to have a compressor failure. You're going to end up with a really irritated homeowner. And as I said earlier, it's a loss of repeat business. There's a lot of people that'll say to me like, hey, I've never had this. I put 3/4 inch piping on every water to water I ever did. They never called me back. I know it's not a problem. The reality is they didn't call you back. You went in and installed it. You put the 3/4 inch piping on it. They called your competitor. So your competitors probably made a real good business out of following behind you, fixing the things that you didn't know. And again, I'm sure there's nobody on this call that's doing this. I just like to communicate my experience and what I see, because unfortunately, as the technical rep for Ontario, I get to see all of this a little bit more frequently than I would like to. The other thing to keep in mind is there's really cost-effective ways to design your system to make it work really well. So on the right-hand side here, I have a PEX installation from a company called Nottawasaga Mechanical. And so we could have designed that system around 120 degrees. But again, I'm trying to get that COP up. And just in bringing the COP from 120 to 109 makes a huge difference in the overall COP. How did I get from 120 to 109? How much money did I spend? How many thousands, tens of thousands of dollars? Try $200. Instead of doing 12-inch spacing, which is what you see illustrated here, all we did was tighten up the spacing to 6-inch. So we went from 141 feet of half-inch PEX, and $200 is probably an overstatement of what that costs. And instead, we're using 269 feet of half-inch PEX. The least expensive part of the installation. I didn't change the heat pump. I didn't change the building envelope. I added cheap tubing, and I was able to bring the supply temperature down. So again, little things that we can do to actually get it down. The other thing to look at is, could a water-to-water actually heat any home? So I've got a whole bunch of math on this screen, but at the end of the day, I've taken worst-case scenario of 25 BTUs per square foot for a 12 by 12 living room. 25 BTUs per square foot screams, did you leave the window open? But I'm using it intentionally. Even at a 25 BTUs per square foot, where I'm trying to achieve a 68 degree ambient temperature, it means that I need 130 degrees leading that unit. There are multiple brands of water-to-water equipment on the market that can absolutely produce 130 degrees, but pay attention to this slide. How many houses actually need 25 BTUs per square foot? If you work off of a design 9.9 times out of 10, you're not using 130, you're using 110, 120, which a water-to-water unit can deliver no problem whatsoever. Let's say you get into a scenario, you got mice and rats, whatever the case may be, you absolutely need to have a higher water temperature. This again is the hybrid heating discussion. This is my buffer tank. There would be a water-to-water over here. So I'm keeping this buffer tank at 120 degrees. Downstream, I can see what's calling and I can control it through my relay box. This boiler will only come on when this buffer tank is not producing usable heat. So what I mean by that is, if my emitters only need 120 degrees, this buffer tank is just being charged to 120. If I actually needed 140 down here, because maybe this is mice and rad that's installed, This boiler will sense the temperature in this tank, will see that it's not warm enough to do this, and it's very simple. It comes on and lifts the water from 120 to 140. So all my boiler is doing is lifting the water 20 degrees. What you're noticing here is this is also a use for my domestic. I personally don't like using my water to water for domestic, unless I don't have another heat source, then I will. But if I have a backup boiler, why wouldn't I just use that boiler to take care of that domestic load? So lots of different ways to do it. The takeaway from this one is just to understand that there's a lot of hybrid approaches where instead of me putting in a 6-ton water to water, maybe I put a 4-ton in. And this boiler comes on 1 week out of the year to heat the space. The company that's doing that is putting together a very efficient, cost-effective solution at a far lower price point than other people would be. And again, designed for the correct water temperature. I talked about my house. This is what's in my house. There's a lot of different products on the market, but this is called ROW panel. So ROW panel can produce up to 30 BTUs per square foot with a mean water temperature of 110. So for a water to water, we could deliver 30 BTUs per square foot. This is much more expensive up front than just putting PEX in. This is a heavy gauge extruded aluminum that I could put out in the street and drive over all day long. It's not going to have any problems with that. So I paid more money up front. I only do this once so that every single month when my electric bill shows up, I'm paying less. I've future-proofed my system because the rate that inflation is going, my bills are all going up, but mine are going up less than everybody else, because if this would have cost $3,000 to do regular PEX and my system costs $6,000, I don't care because I understand why I paid $6,000. You need to be conscious of that when you design systems. If you're offering dry panel systems, understand they're more money up front, pardon me, but what does that mean to the actual homeowner? And so here's a table just illustrating different options. This comes courtesy of Rayhow. So you can see the ROW panel at 30 BTUs per square foot. You could see 8-inch spacing. So in my house, if you look at the picture, I have burring strips that came with the system. I'm doing 8-inch spacing, which was more cost effective, less aluminum, and that still gives me 28 BTUs per square foot. This is at 110 degree water. I don't need 110 because I don't need 28 BTUs per square foot. So when you hear me heating at 95 degrees is the coldest day. I'm heating my house sometimes with 89 degree water. So again, not for everybody, but if you can design your systems, it's going to make a world of difference. The other thing to think about is that if you need an emitter, if you're thinking you need one of those rads that you slap on the wall that can do the heating, look at products like low H2O convectors. These products have the ability to do heating and cooling, and they're designed to produce usable heat at 95 degrees Fahrenheit. So it's the same conversation with the dry panel systems I was showing you. Use this technology. It makes a world of difference from the standpoint of overall cost of operating that system. This is more money up front than me just slapping a rad on the wall, but overall efficiency. And the other thing is aesthetics. It looks really nice. People are not putting geothermal systems in because they want to do the status quo. It's kind of the Apple conversation. Why do people stand in line to get a new iPhone when they're sitting there with a perfectly good iPhone in their hand? Some people just want the best system. They don't care about the price. We need to separate ourselves from the, well, what Mike is proposing is really efficient, but it's too much money. We don't get to decide that. We have to let the customer decide that. So have your best foot forward and have a plan B. Have a lower cost solution in case it's not a solution for them. So really quickly recapping everything, boilers are not heat pumps. We went through the piping, we went through the flow rates. You have to design and install these understanding the flow rates. Buffer tanks are a must. We want to make sure we let that unit run for a minimum of 10 minutes, maximize the efficiency of it, pay attention to flow rates, pay attention to controls. And the other thing is try to use that buffer tank as your actual load profile. I don't really care what's happening in the house. I want to make sure that I'm charging that tank to what the heating or cooling needs are. And I can use off-the-shelf controls to make sure I'm doing that efficiently. You don't need to have some fancy engineering or controls background to make it work. Big takeaway is always remember, heat pumps are not boilers. They also can cool. So I say that because you can do cooling, but also be careful. We want to make sure if we're doing a radiant floor system, we're not inadvertently forgetting this thing's going to do cooling and start pumping chilled water into a slab. We're going to have all kinds of problems. Pay attention to design, read the manual, check and see. If ClimateMaster sold you a unit, what size tubing or piping did they say has to go on that? There's a reason for it, and warranty does not cover us not reading the manual. We talked about lower water temperatures. The lower we can bring that water temperature down, the higher the COP. The difference between 100% efficiency and 450% efficiency over the 25-year lifespan of a heat pump is significant. You're talking $100+ a month for 25 years. The homeowner will thank you if you can design your systems with lower water temperatures. And again, remember, that doesn't always mean it's more money. You can design systems that work at lower water temperatures for the same price as your competitor because you had the word design. You didn't go out and just threw tubing down on 12-inch spacing. You had somebody do a design, you tightened it up to 9-inch or 8-inch spacing. Now you're at 100 degrees, not 120 degrees. And again, it comes back to future-proofing your designs. Keys to a winning installation, want to drive it home again? It's you guys, the contractors that are installing the work first and foremost. You can have an awesome distributor, you can have an awesome manufacturer. If the contractor doesn't know what they're doing, it's a challenge. In the same token, an amazing contractor with a mediocre distributor and a manufacturer may not be engaged with you, you're going to do great work. If you're a great contractor and you got a great distributor and you got a great manufacturer, guaranteed you're well known in town and you are probably the best geothermal installer in your city, and you should be proud of that work. Don't chase after those guys that are cutting corners and doing things going, well, I can do it for $3,000 less because I'm just not going to do X, Y, Z. The reality is those people come and go. I've done this now for 22 years. Plenty of people have come into Ontario and said, we can do it better. We can do it cheaper. It's tough for me because I like to be the guy for everything. But sometimes you just got to sit back and say, you know what? They're not going to be here in 5 years. And what I can tell you, and you probably know this from your own experience, the people that don't follow along and pay attention and follow good practices, they don't last. They're not in this for the long run. If you install a unit and it doesn't work, it's a black eye for the whole industry. If you see a unit that doesn't work, help them. Even if you didn't install it, if you fix that installation, it will pay you dividends in referrals, and that customer will be your best marketing tool over anything else you could spend your marketing dollars on. So on that note, Jeff, I'm done. For everybody watching, if you're keen on watching a 2-hour version of this, there's a very lengthy, detailed one on our YouTube channel. I've put my contact information on here. If there's questions, comments, if you've got an installation where you're like, I wonder what Mike would say about this, I'm just that guy who likes to help people, no strings attached. You're welcome to email me, hit me on LinkedIn, hit me on Instagram, and I appreciate everybody coming and giving me an hour to talk.
Well, thanks so much, Michael. That was a great presentation. I'm sure a lot of people will look for that YouTube video. We could have used 2 hours for sure, but we were limited to one.
This is normally a 1-day training class, as Jeff knows. So to ram it into an hour, I apologize. I had to go pretty quick.
That's quite all right. It was very, very useful. We do have just a few questions. I will follow up with Michael after the webinar with those questions, and then we'll get back with those who submitted them. Thanks again for joining our Dig Deeper webinar. Check out the IGSHPA website for future events. If you go to the events and training menu at the top, you'll find what's coming up. This will be recorded, so check back in a couple of days. There's an icon that says YouTube at the top of the IGSHPA.org page. And when you go there, you'll find the recording with Michael's presentation, or as he mentioned, if you want to see the whole thing, go to youtube.com/Eden Energy Equipment. Thanks, everyone. Have a great weekend, and I appreciate your support of IGSHPA and our webinars. Take care. Bye.
Thanks, everybody.